Oh, hey, Josh.
Hey, Devin. What are you doing up there?
I'm just kind of floating around.
How?
I just grabbed the balloon.
I don't think that's how that works.
It's not. Hey, spaceheads. I learned a lot while I was up there about the atmosphere and everything. Like, did you know that the oxygen that we breathe is only 20% of the atmosphere? Crazy to me. There's a lot more to it, but in order to get the real gist of it, we're gonna have to go to the headspace. Come on, let's go. First, we'll start on the atmosphere. You see, there are 4 layers to this thing: the troposphere, the stratosphere, the mesosphere, and the thermosphere. Now, the wildest part is that the clouds are just on the first layer. See, after the clouds, there's still 6,102 miles of sky to go. Can you believe that? You know, without the 6,114 miles of atmosphere, you'd have the worst sunburn of your life. You see, the gases in our atmosphere filter out sunbeams to keep us safe. Those sunbeams are absorbed by the gases in our atmosphere. But what really is gas? Good question, spaceheads. You see, everything has atoms. And in each state of matter, these atoms have particles that move around closer or farther from each other. Solid having the least amount of space between particles and gases having the most. Oh, looks like it's time to keep the show moving. I'll see you guys around.
The atmosphere protects the Earth.
Items also tend to burn up when they enter the atmosphere.
If there's no carbon dioxide in the atmosphere, the Earth will freeze.
The atmosphere is everything that's between the Earth and space.
Did you know that propane can set stuff on fire?
So, gases are the highest in energy of the states of matter. The atmosphere is mostly composed of nitrogen, about 80%.
The 3 states of matter is liquid, solid, and gas.
Science can be way more dangerous than you expect. Gas turns into a solid. It's called deposition.
That it surrounds the Earth.
The country Belize is the only country that has humans on its flag.
For today's experiment, I thought we could demonstrate certain aspects of gases and how the environment affects them. But for that, we need an expert. So I brought in
Cameron Lamar. I'm an instructor here at Astrocamp.
Now, I muted him because I don't want to give it away. But what do you think happens to the balloon in the vacuum chamber when he turns it on? Is it A, grow, B, shrink, or C, order a 2-topping medium pizza for only $7.99? It orders it grows, yeah. Wait, so what happened?
So we can take the air out of this chamber. The pressure goes down. That's the force pushing inside on the outside walls of the balloon. But there's still air trapped inside because we tied it off. So the air inside the balloon wants to decrease its pressure now to match the outside pressure. So it's going to start expanding. That air can spread out and breathe a little bit. But that air is still pressing pretty hard inside, and that can push so hard that it can pop the balloon. These are made out of the 2 lightest elements in the entire universe: hydrogen and helium.
I knew it!
Can you guess which balloon is which?
Very slowly. Bring them closer together.
Oh!
Which one was that?
Oh, shit!
Was that the hydrogen or the helium?
Helium.
So one difference we like to share in identifying helium from hydrogen in our class is actually to, the hydrogen is really, really flammable. What's going on here is we are introducing a lot of energy to the densely packed hydrogen gas. We bring in a flame. That energy can actually break the bond that holds the two hydrogens together, and then they can react with the oxygen in the air, just as a single hydrogen instead of H2 hydrogen gas. Once it starts reacting with oxygen, oxygen as an oxidizer will allow it to start heating up. Hydrogen is extremely flammable. A big spiral out of fire starts going until all that hydrogen has combined with the oxygen, and we actually also get H2O out of this water. That's the main byproduct of the reaction.
Now before we go, I'd like to try something. You see, I'm still pretty upset that I fell out from the sky earlier, and I'd like to get back up there. So I did a little bit of sciencing, and I found out that helium is lighter than air, which causes a sort of upward force to go, well, upward. And so I'd like to figure out how many balloons it would take to get back up there. Figure that out right now. I'll do the math. Carry the 2, divide by my birthday, and 5,000 balloons! Oh, guys, I'm going to need a little bit more time. I'll have to see you guys next week.
Wait, was it you that tied the snares?
This program was made possible by our various camp programs and by donations from people like you. Thank you.